Thank you for coming to the session. I'm sure I'm not alone. I'm a Java developer. I've been involved with Java for many years. And over the past years, quite clearly, there's a lot of focus in many places on JavaScript. And I'm sure, like many people, I've resisted JavaScript for as long as possible because the Java language is in many ways better, you can say. The ecosystem is much stabler and much more reliable. I'm creating enterprise applications, business applications, kind of in finance or healthcare or logistics or those kinds of business scenarios. The Java ecosystem is fine. However, there's this constant push towards JavaScript, and in this session I want to share some insights I've gained over the past couple of years about where JavaScript might make sense and how best to approach JavaScript from a Java background. And it's a pretty big crowd here. We're at a Java conference, and clearly there's always constantly interest in JavaScript as well. And the question I want to ask is, what can we do with this language and this ecosystem in the context of business applications, in the context of applications that need to not be written once and then kind of forgotten, but that need to be written and maintained over many years and that have business requirements. How can business requirements be met with the JavaScript ecosystem? And those kinds of topics I want to address. And I believe that the reason for all of this is the mobile phone. And what the mobile phone has, apart from being in everybody's hand, is the browser. The browser is a platform that is on all devices. The browser is on your mobile phone, on your tablet, on your desktop, on your laptop, on any device there's a browser. And of course, the native language of the browser is JavaScript. It's built into the browser. So it's a logical question to ask yourself whether the front ends, at least, I'm very specifically talking actually about front-end development, that the front end of an application, to explore the possibilities that JavaScript offers there, and to see what kind of solutions there are. These are typical business applications. The first one is a Tesco application for the internal employees, for the staff of Tesco to manage their time schedules. And the next one is a healthcare-related application showing blood work results. And the third one shows a map, a very typical aspect of a business application. This is an application created in Belgium by a company called Contribute, contribute.be. And it's for truck drivers in the Antwerp harbor. They can fill in a booking number, and then on the map they can see where they need to go to deliver their product. And on the final one shows you again a business type app, but it's been internationalized. So you can see the kinds of concerns that you have when you're creating these kinds of applications. So these are not games or toys. These are business applications. Time scheduling, displaying graphs and charts, some kind of result, a map, internationalization. You have concerns that are kind of common in these different kinds of applications, in terms of data visualization, in terms of the architecture of these applications. Internationalization is a typical concern of an enterprise application. Accessibility, that you have different kinds of screen readers plugged into your system for people with disabilities and so on. So what does JavaScript help us with in this context? What aspects of the JavaScript ecosystem can we leverage to create these kinds of front ends for these kinds of business applications is the topic I want to look at. So my name is Geertjan Wielenga. I worked for a long time in Sun Microsystems, and then now I'm working in Oracle. In Sun, I worked a lot on Java and on NetBeans, and I'm still working on NetBeans. In Oracle, at the moment, you may or may not know this, but we're moving NetBeans to Apache. So it's going to be Apache NetBeans. And a lot of Oracle developers will be involved in that project, as well as developers from Red Hat and other organizations. So it's going to be the first development tool, the first IDE that will be in Apache. It's a long process that we're going through. This is whole incubator that we're in right now, but it's going to be really good, I think, once everything is sorted out. The other thing that I work on in Oracle is Oracle's JavaScript platform. So I'm going to mention that a little bit. It's a free open source toolkit of solutions called Oracle Jet, Oracle JavaScript Extension Toolkit, and it's one example of how you can solve typical business problems by means of JavaScript. There's all kinds of large enterprises nowadays involved with JavaScript, which wasn't true 3 years ago. 3 years ago, you didn't have Oracle and IBM and Salesforce and SAP and Microsoft and PayPal and all kinds of organizations not only using JavaScript, but even providing JavaScript-based solutions. So clearly something has changed, and that's kind of the focus of what I would like to talk about. So I'm from Amsterdam, and this picture was very famous on Twitter a couple of years ago. And what you see in the picture is the most famous Dutch painting, the Nightwatch by Rembrandt, hanging in the main museum in Amsterdam. And there's like a big room almost dedicated to this painting, to the Nightwatch. And in front of it, you see a bunch of kids with their backs turned to this great work of art and focused on their mobile device. And this actually, this picture caused a major uproar in the Netherlands for some months. You know, it was almost like there were questions to the Prime Minister. You know, what does this mean? You know, the youth of the future care more about Facebook than about Rembrandt, and you know, these kinds of things. And people were really upset. You know, what does this signify? This picture. However, it then turned out that right before this picture was taken, the picture on the right was taken. And that same group of kids, teenagers, were actually focused on the painting. They were being taught, they were learning about the painting, and what they were actually doing in that picture that caused so much concern is they were researching. They were looking at the museum app. They were engaged with what they saw around themselves. They were not distracted. They were not switched off from the art and looking at their Facebook. In fact, instead of that, they were engaged and really researching and finding out more about the painting and about Rembrandt and et cetera, et cetera. So there's really been a couple of years, and it's not so much now anymore, where people really thought that this whole mobile phone direction was a sign that people were switching off from reality and moving into this very private, self-defined, individualistic space. But instead, I think in the meantime, there's a lot of indicators that it's the other way around, that what the mobile app offers us is a new way of engaging in reality. And in the business space, these mobile apps are often written, typically written, increasingly written in JavaScript. Now, why is this? There's of course the whole debate of native versus hybrid. You know, should you write your app in native Android, native iOS, or should you use JavaScript? If you're doing business development, if you're creating these kinds of applications, it's normal to use JavaScript on the front end. If you're creating games or things where you really need very high performance, that's when you do native development. But for these kinds of applications, of course, the application needs to be well performing, but it doesn't need to be performing as well as a native app would allow. So this explains, I think, to a very large degree why there is so much interest in this whole JavaScript ecosystem, which wasn't the case, before all of this mobile app craze or this surge of mobile apps came about. So what I'm doing here is I'm not advocating, I'm not promoting JavaScript as such. I'm just saying that all the devices have a browser. In the browser, in all browsers, there is JavaScript. It makes sense on the front end to explore the possibilities of JavaScript, and on the back end, I mean, I'm really Java is ideal for the backend. Use REST and serve up REST endpoints, integrate those endpoints into your front end. The Java ecosystem is perfect. It's for that. It's a slow-moving organization, company based on decisions, and everything takes a long time, which is great. And everyone has to agree on things together before there's the next release and things like that. And there's a community, and there's a massive amount of libraries. Why would you not use Java on the back end? Especially for larger applications or for business applications. But here I'm focused very specifically on the front end. And of course, the key problem is summed up by this picture here. There are just so many choices, which is great if you're creating a little prototype or a game and you want to play with some libraries and put a game together or a small app and publish it to the App Store and work on another thing. And you don't care that everything breaks because those libraries are not being developed anymore next week. And you don't care that things don't work so well together. You like hacking. But if you're doing business applications, that kind of environment is not ideal. You want something with well-established APIs and a well-established way for the different parts to work together, and well-architected, well-thought-out infrastructure of the application, and those kinds of things. And those kinds of things are not typically what you find in JavaScript. It's really focused on quickly putting things together and putting it out there and working on the next thing. So it's a bit of a conflict between those two different worlds. So to sum it up, JavaScript happens is kind of the situation that we're in, and how to best deal with it is what I would like to focus on. These are kind of 10 insights I've had over the past years while getting into the JavaScript space that I want to talk about. So the whole session is going to be focused on each of these 10 points. I'm going to talk about resisting the hype, about looking at HTML5 again in a different way. I'm going to talk about responsive design and that JavaScript might be more useful than CSS in some cases. And I want to show you some JavaScript solutions and what they do in the context of responsive design. I want to talk a little bit about this problem of choosing the right library to use. How do you choose? A few years ago, everyone was talking about Backbone, and then it was Angular, and now that Angular 2, is it so backward compatible with Angular 1? Now a lot of people are looking at React, and how do you make those choices? What's the right approach to take with this constant change? I want to look at modularity. Really a useful aspect, of course, when you're creating a business or larger or more structured applications. Look very briefly at abstractions over the standard languages and technologies. Briefly look again at the ecosystem volatility and tell you about a term. Instead of write once, run anywhere, there's a wanta instead of wara, and we'll look at that. I want to talk a bit about the corporate frameworks, which really signify to me that the JavaScript ecosystem should be taken seriously. Because large organizations have really committed, like the large enterprises, the large vendors, are really in this space, which wasn't true 3 to 5 years ago. And maybe, as a final point, I want to suggest to you, we could look at JavaScript as an assembly language, and why that is, and what the consequences of that are. That's basically the structure. So first of all, resisting the hype. So there's this amazing plate of cookies with these wonderful technologies, and every conference you go to, you learn about something new. Even though you're at a Java conference, you learn about interesting JavaScript things, and you think, hey, that would be great to use. And you start combining things together, and it works for a while in the beginning as a prototype, and then you go into more production environments, and then you come into the real corner cases and bottlenecks and all kinds of problems. So the first step I would suggest is to resist the hype, because this whole browser story doesn't apply to each and every scenario. It's not a silver bullet, of course. So very clear example, an air traffic control system. So an air traffic control system, if you ever end up finding out that you have taken a plane whereby the air traffic controllers in the tower have a mobile phone that they use to decide whether your plane should land or not, you should probably take a train instead, because in many scenarios you need a large resolution. You know, air traffic controllers need a large screen, very simple. And also in many scenarios, the users of an application are all in the same room together. So these you could say these are very niche scenarios, but there are many of these niche scenarios. For example, you know, 30 air traffic controllers in the same room. Why would they need their application to be in the browser? They have a perfectly fine Java desktop system that's been working forever, and their manager says to them, hey, probably we should have a browser-based application. Or the manager of the developer says, hey, maybe we should be creating this application in the browser. It's never the users who would say this. There's never a user who would, it's never an air traffic controller who said, I want this to be in the browser. There's never been a developer of air traffic control systems who said, I want to create a browser-based application. It's always a management-driven thing. You know, we need this to be in the browser, much simpler to deploy. We can have it on the mobile device. It's all much simpler and easy and so on. So, my first suggestion is, in this context, is to resist the hype and to make the argument that these new devices, this mobile device and the tablet and the web app and so on, that they be used to supplement the existing system. So instead of rewriting everything to JavaScript, make the argument that maybe we do need a mobile app, but only to receive notifications. So we keep the system as it is. The air traffic controller uses it exactly as before, but they also get a mobile app and they get a little signal whenever there is some emergency or something in the mobile app, focused on just on notifications. And we'll keep the system exactly as it is, but we'll also create a web app for the managers to see statistics, to see graphs and charts and so on. But the system itself makes complete sense where it is. So this is, and this is something that I see quite a few organizations doing, you know, making this kind of argument to modernize, not by replacing everything, but by supplementing with mobile apps, with web apps, with charts and graphs and things like that. The second tip I want to briefly look at is HTML. So you might think that we need to do everything now with JavaScript in the browser. But HTML itself provides a number of features out of the box. You should look at HTML again, look at the HTML5 specification. You should take a look at it because it provides more than what you think. So originally, of course, HTML was meant as a markup language for scientific documents. And in the meantime, there's been all these multimedia experiences in the browser, animations and audio and so on. And so you might think that HTML5 is only focused on multimedia and audio and these kinds of functionalities. But there's actually more to it than that. And that is, for example, auto-completion, IntelliSense. So I'll do a very quick demo to show you this. I'm just going to open this little application, empty application in the browser. Add a little drag and drop here. So here's some HTML5 snippets. And what you see here is a input element, exactly as there's always been an input element in HTML, with the difference that the input element has, first of all, a required attribute, which is new. So there's error validation built into HTML, which is useful if you're creating applications. And also there's this list attribute. So the list attribute, just one of many new attributes in HTML, connects this input element to another new HTML element called data list. And a data list provides here a number of different items. And if I look back in the browser, I can see that if I click on this drop-down, which was created for me, automatically I get these countries that I've listed here. And there's actually a filter built into this too. So as I start typing, you can see that this filtering feature is automatically provided. So all browsers supporting HTML5 have the possibility of doing code completion, IntelliSense, via pure HTML5. So there's no jQuery, there's no special library here, it's pure HTML. So my tip here is to look again at the HTML5 specification. This basically are the principles of HTML5. Everything should be based on HTML, CSS, JavaScript. No external plugins like Flash. Error handling is built in, for example, that required attribute. Markup, and of course device independence, because this is all focused also on the mobile experience. And here is a quick example that I showed. One of many interesting application type components, so not multimedia related. So that would be a second tip when approaching the whole JavaScript ecosystem to examine what HTML5 provides. The third tip, normally when you hear about CSS, you think about media queries because you're doing responsive design. But what JavaScript provides, there's a number of interesting JavaScript libraries that actually do what you might be assuming media queries do. Case in point, very simple example again. Here is a starting point of an application I'm creating, let's imagine for Coca-Cola. This is how the application looks in the browser on the desktop. However, when I want this application to be shown on a smartphone, what I would like is to not see that logo because it takes up too much space. So when I'm on a mobile device, there shouldn't be a logo. It takes up too much space. If I was doing media queries here, what would be happening as I make this browser large and small is that that logo would be shown and hidden, but still be present in the DOM. However, in this case, it's not present anymore in the DOM when I'm in the mobile resolution. So we can see this in action. So I'll just move this along so we can see them next to each other. So here's the browser, and here's the development tool. And what we can do is we can open a small little window here that gives us a view on the live DOM. So here's the DOM. We connect these together. And so let's make this bigger to see that logo. Now if I click on this logo in the browser, you can see that on this side a div is selected. If I select something different, you can see a different div is selected and so on. But here we are in that div that is that logo. You can see here's the logo. Now, as I make this smaller, look what happens to that. So there are 4 divs right now. Make this smaller, and now there are 3 divs. And now there are 4 divs. And now there are 3 divs. And now there are 4 divs. This effect is not done by CSS, but it's done by JavaScript. So let's take a look at how it works. So you can see here that there is this, so in this example here, we can see there's a data bind here, so we're using a knockout in this case, but the important thing is here this variable, we are small. Now where does that come from? It comes from being set here, so here we say, we define that we are small variable, but here we have some breakpoints. And these breakpoints come from a library called response. So response.js lets you set breakpoints, and based on those breakpoints, you can set a variable. And so if you find this an interesting concept, the library related to this is called response.js. So you go to response.js.com. So it provides you breakpoints. And once a breakpoint is set, you can set your variable. And based on that variable being set, you can either show or hide your items. And what then happens is that that element is removed from the DOM and added back into the DOM by that JavaScript library. Another one that does something similar is foundation interchange from Zerb. So that would be my third little insight here, that don't only use CSS for responsive design, but also use JavaScript. CSS shows and hides elements in the DOM, while what JavaScript is for loading and unloading elements. And then the fourth point, how to evaluate this crazy ecosystem of all these different libraries, all these different technologies. You know, a couple of years ago, Backbone, and then it was Angular, and now a lot of people are not going to Angular 2, but they're going to React. And there's always Ember, and there's Ext, and then there's libraries on top of base JavaScript. And there are testing libraries, and then there's Yoan for scaffolding, and there's Bower for dependency management, and there's Ionic on top of Angular for mobile, and so many different choices to make. The typical thing that people do is you start out by categorizing these different things into different categories like this. For example, with the build systems, you first spend some time learning Grunt, and then you're very happy that you can do Grunt, and you tell your colleague, hey, I know how to Grunt, and then the colleague says, yes, but Gulp is the new Grunt. You should learn Gulp, and then you spend time learning Gulp, and it turns out Brunch is the new Gulp. So potentially you can continually, it's a continual learning ecosystem, but at the same time that makes it very fragile. What are the right choices to make? Do you need to always choose the latest, most hyped thing, or do you choose something that is slightly older and more stable and will be less impressive when you tell your friends about it? No one's impressed by Grunt anymore, but at least Grunt is stable, for example. So how do you, do you always go for the latest, most cutting-edge solution, or do you go, especially in the context of business applications, you want to use things that are slightly stabler and more reliable, and that have been around for a couple of years, and that have a community and documentation and questions being answered on Stack Overflow. So don't always follow the shiniest object. But in general, the two approaches are, as always, true in Java, true in Ruby, true in any language. Do you go for a big framework that provides everything? Or do you go for the library approach where you choose a couple of small libraries and you combine them together and you build on that? And of course, there are advantages and disadvantages. With the framework approach, you have everything, but it may be a lot more than you need. And when you move from one version of the framework to the next version of the framework, how backward compatible is it? And how easily can it be extended? Is maybe not the right approach to take the library approach, because this is more flexible. And if you choose your architecture based on the bunch of libraries, you might be able to add new libraries into it more easily and remove libraries from it more easily than if you take a complete out-of-the-box framework that provides everything and that locks you into its ecosystem. So these are considerations. There are no answers. Incorporate modularity. So of course, one thing you really need to think about is the architecture of the application. Maybe more important than ever, since things change so quickly. Set up the architecture of the application so that it's loosely coupled, and all the pieces are communicating well with each other. Everything works in a loosely coupled manner. It's well architected, so that somehow you can replace that UI layer relatively easily. Use REST endpoints, use all these standard approaches in modern architecture. In the JavaScript ecosystem, there are various modularity solutions. For a long time, JavaScript itself didn't have modularity, but now in the latest release, ECMAScript 6, the modules are included there. Require.js is a good solution to use. It's a bit older as well. Browserify too. System.js you might know if you're using Angular. It's kind of the Angular approach to modularity. But choose something to break up the application to make sure that you don't have to handle the file loading yourself. Because by default, you have an index file, you list all the JavaScript files you want to load, and you have to load those in the right order, and you have to think about that on your own. So you need some kind of file loading mechanism or some way to break up the application. So the other point is you don't have to use pure native JavaScript, CSS, and HTML. You can instead of that use abstractions on top of it. And the obvious ones are TypeScript, gives you a type system, CoffeeScript, Sass, less for post-processing, pre-processing CSS, Emmet, very nice, integrated into all the IDEs and editors, gives you a very small syntax for generating HTML, emmet.io, and it lets you curate, you can write in UL and an arrow and then LI times 3, and it will generate an unordered list with 3 list items in it. A small syntax for doing HTML. So the real big concern in all of this is the volatility of the ecosystem. And the the only thing that you can really say is, if this is really a problem for your software, if what you are writing, if your applications have a problem with the volatility of the ecosystem, then maybe this ecosystem isn't the right place for your application. It's not a one-size-fits-all. You can more or less see that the lifespan of your app should be equal, more or less, to the lifespan of the current release of the framework you're using. So every year and a half, 2 years, there will be a new release of the libraries and the framework that you're using, meaning that you're going to have to rewrite parts of your application. If you were going to rewrite your application anyway every 2 years or so, then this is a very good fit. But if you want to be in a situation where you have a system that shouldn't change in a big way in the next 10 years, then maybe this is the wrong ecosystem. But this is all kinds of problems. If this ecosystem is one in which people write apps and then publish them to the App Store and then write a new app and publish to the App Store, then what about maintainability? What about readability? How important is it that your code is readable if you know it will never be maintained? So this definitely has all kinds of consequences. If it is a good fit for the things that you're doing, then this is a good place for your applications. And this brings us to the from write once, run anywhere, to a term that you could associate with this picture, which is write once, never touch again. And again, if that fits the applications you're writing, a lot of organizations are writing quick mobile apps, publishing them, writing another mobile app, publishing that, never touching it again. Then this is really the perfect ecosystem for that. So the almost final point is the corporate frameworks. And I think this is one of the really interesting things that have happened in the JavaScript ecosystem. One of these, Kraken.js. You may or may not have heard of Kraken.js. This is a framework based on top of Node on the back end and Express on the front end. And where does it come from? PayPal. So I went to a conference and there was a keynote by a VP from PayPal. And I thought, what does a VP from PayPal have to say to developers? And it turns out PayPal has an open source division and they do all kinds of open source things. So they were using Node and Express internally. And at some point, they added some components that customized it. And at some point, they open sourced that. And so now the VP of PayPal can go to conferences and talk to developers. And all these organizations are competing with each other for developers. So this open source direction enables the large organizations to do that. So I've mentioned PayPal now. Another one is ING. So on GitHub, you can find ING's framework on top of Angular. And SAP has a JavaScript approach, and Salesforce, and IBM, and Microsoft, and so on. In the case of Oracle, there's this Oracle Jet. So you can go to oraclejet.org, and you'll find yourself on a page where at the bottom you can see jQuery, jQuery UI, Knockout, Require. So these are the libraries that are being used inside Oracle for front-end development of applications. So if you're familiar with Oracle, you might know that there are things like Apex and ADF, and now increasingly the front ends are being written in JavaScript. And you can use the same technology that Oracle uses, the same approach, in the creation of your own applications. And in the same way as with Kraken, there's a getting started page. So with Oracle Jet, you can do node install Yeoman, and then you have Yo Oracle Jet, and you can also do Yo Oracle Jet Hybrid, which will give you a Oracle Jet application with a Cordova folder. So there's integration directly with Cordova built into this. And the applications you create are similar to these. So here is a kind of the reference implementation of an Oracle Jet application. You can see there's responsive design built in here. It's a single-page application architecture. You can drill down into the application, and what you see here are graphs and charts. And these are graphs and charts created at Oracle. They're on GitHub, github.com/oracle/oraclejet. You see a long list of JavaScript files, and these are jQuery UI widgets. So for example, you can see here this OJ color, this OJ chart, OJ button. These are all visible in a cookbook on the Oracle Jet site. And these jQuery UI widgets you can use without using Oracle Jet. It's completely separate. So if you're doing Angular and you're looking for a charting library, for example, there's a whole bunch of charts that are part of the GitHub repository, and you can take those charts and use them in your application. And in the cookbook, you will see for each of the components there is literally a recipe. So we can see here there's a toolbar along the bottom of this chart. So we can see here on the right-hand side that there's a recipe for how to put this in my application. And I can tweak it directly within the browser. So I'm in the cookbook, and I don't want to have the toolbar in my application. So I can just tweak directly in here, remove this whole div, and then say apply, and now the toolbar is gone. And now I can copy this HTML into my application and this JavaScript into my application. And what all these different solutions also provide are ideas around convention over configuration. So in the case of Oracle Jet, there's always a view models folder and a views folder by default, but you can override that. And in the view models folder, you can see the JavaScript files, and in the views folder, you see HTML. Now, what are these JavaScript files? They're just require.js define blocks. So it's just a define block from require, and here is the view of that define block. So here you can see dashboard.js, and there's content, and here is the dashboard HTML. And there are ideas built into this for internationalization. So here's a simple example of that. You can see here we have English and French and so on. And here's a date and time picker, which is one of the many components that are part of the Oracle Jet component suite. And you can see that when I hover over this, I can see in English there select date. And when I'm in French, I can see here it's that tooltip is in French. And I didn't translate that as the application developer, but instead of that, in the Oracle Jet library that is included in each application, you will see that there are translation bundles. And these translation bundles automatically translate all these texts. And you can see right to left support and things like that. So these are typical concerns of enterprise applications: internationalization, modularity, the architecture of the application, setting it up, templates, documentation. These are the things to look for when you're creating larger applications. And it really makes sense to look at what are these organizations doing, and to base your JavaScript front end at least on top of PayPal or on top of Salesforce or on top of IBM and so on, because you know that these organizations are invested in these stacks that they have made available. Because all of these organizations, whether it's Microsoft or IBM and so on, they're all interested in cloud and in creating cloud front ends of different kinds. They have requirements such as these, so responsive design, modularity, single-page application architecture, accessibility, internationalization, security, performance optimizations, standards where there are in JavaScript, documentation and support. So these kinds of enterprise concerns are solved by these enterprise-focused solutions. And it makes sense to explore those possibilities. So, and there's a Twitter page, and there's all these kinds of community-orientated results for working with JavaScript in the context of the enterprise. The final point I want to look at is that if you really don't like JavaScript, a final approach that you can take is to consider it not as a programming language, but as assembly language. So you might wonder, how is JavaScript assembly language? You know, this is assembly language. How does this relate to JavaScript? Well, this is JavaScript, right? To me, it looks a lot like assembly language. Okay, I cheated, I minified it, and all kinds of things. But this is JavaScript. Would you want to write an application using this language? If you're completely honest, this is not this is something that the machine needs, and the machine is the browser. But this is not something that you, as a developer, would ideally write in. So there's a really interesting page on GitHub, github.com/yashkenas/CoffeeScript/wiki list of languages that compile to JS. And in here you see a very long list of different languages. and their solutions for JavaScript. Now, of course, in Java, there's a number that you may have heard of. One of them being Gluon. So you can write your code in Java, and Gluon handles for you how it gets to JavaScript. Vaadin, I think it's quite well known, on top of Google Web Toolkit. Code your application in Java, and Google Web Toolkit is used to transpile that to JavaScript. GeeCScript is a really interesting one, I think. It lets you write your application, your business logic in Java, and your view in HTML. So the view is in HTML, and the business logic is in Java, which enables you to give your view, your HTML files, to a web designer, and they can do all the design and whatever, and you get it back from the web designer, and you can hook those components from your HTML into your Java using Knockout. So the Knockout library, but there is a Java implementation of this created by the GeeCScript team, enabling you to do that. So and there are Maven archetypes for this. So you can type Maven archetype, a GeeCScript, blah, blah, something, and it will generate a set of archetypes for you. You write your code once, you write your Java code, and you write your view in HTML, and then when you compile, what you get during compilation is an Android APK file, an iOS file, a desktop application using JavaFX WebView, and it has its own transpiler to JavaScript, so that will create for you your JavaScript from your Java code. So if you like this this kind of Java-centric approach, and you don't want to work directly in JavaScript, that's one solution to look at. And another one is Codename One. So Codename One provides a similar solution: create mobile apps in Java for iPhone, Android, and so on. So I would compare Gluon to Vaadin, to GeeCScript, and to Codename One. These four solutions. Okay, so you can compare GeeCScript to Vaadin. It's kind of similar, but there are distinct differences as well. So in the case of Vaadin, by default, you write your view and your business code in Java. In the case of GeeCScript, only the business code is written in Java, and the view is written in HTML and in CSS. So to summarize, a sensible approach from a Java point of view to this JavaScript ecosystem is, first of all, to resist the hype, to try and supplement the existing systems that you have with mobile phones, with web apps, and so on, and not to replace anything. Secondly, to look again at HTML5, look at the specification, look at these enterprise-type components, like the code completion that I showed. Also, very carefully consider whether the JavaScript libraries, especially Response.js and Foundation interchange, might not provide better solutions than what CSS does. Look at these different frameworks and libraries and so on, but just be very careful which ones you choose. Don't necessarily choose the newest, most hyped thing. Look at the modularity solutions, look at the CSS, JavaScript, HTML abstractions over it, so the SES, LESS, and emit. Consider whether this is the right place for the things that you're doing. Write once, never touch again. If that is what you're doing, then definitely this is the right place. But of course, that's a very extreme statement. There are many applications that are not in that category that are a perfect fit for JavaScript as well. But definitely, if you have a very fast development release cycle, and you don't mind rewriting lots of code and you're kind of hacking things together, then definitely this is a good place. If you're doing enterprise development, then you need to be really careful about the choices that you make, and then it helps to look at what corporations are doing and looking at trying to reuse corporate architectures, because you know that those corporations are invested in those architectures, are invested in those ideas. So you can really piggyback on top of what these organizations are doing. And as a final consideration is that JavaScript, just because the browser needs it, doesn't necessarily mean that you have to write your code in it. You could write your code in Java or in something else and transpile from there down to JavaScript. So these kind of building blocks, these kind of approaches, these ways of thinking about JavaScript have helped me and have put me in a much better place of being more relaxed about the volatility of the ecosystem. And I see a lot of promise in the fact that these, the IBMs and the Salesforces and the Oracles and so on are not only developing in JavaScript on the front end themselves, but are also making their own JavaScript solutions available. And a lot of these solutions are open source. I wouldn't have associated IBM and Salesforce and Oracle and so on as open source vendors. And that's really what they are, because everyone wants to have developers, everyone wants to build up a community. There's a lot of competition between organizations for new, cool developers. And one way to do that is to provide solutions that developers can work with. And JavaScript is something that everyone coming from colleges and universities is coming with. So it makes sense that some of these developer-oriented solutions from enterprises are focused on JavaScript. Thank you very much. If you would like to discuss and chat and share some opinions, please feel free to come and chat afterwards. Thank you very much for coming, and enjoy the conference. Thank you.